Hi, a very good evening to dear lecturer. So today I'll be explaining on develop a conceptual prototype model of suspension type overhead line insulator. So we are from group 7. So I'll be introducing all my teammates. So we are six of us. So first Muhammad Zulkarnain bin Mustaza and his metric number CN190048. So myself Aishwarya Rajendran CN190226 and one Muhammad Azim bin one Alida Fairuz AN 190026 and also Muhammad Izwan bin Othman CN 190089, Muhammad Nazmi bin Abdul Rahim CN 190104, and finally Ahmad Amirul Afiq bin Muhammad Fauzi CN 190130. So uh, the table of content actually we will be explaining on our introduction of our topic and also design planning results and also conclusion. So today myself I'll be taking a part of introducing teammates and also about a very minor introduction on behalf of our project. So yeah, as we all know, we had done our practical last week. So we have merged the video of making and also video of testing. So today I'll be explaining roughly about our project. So this is our introduction. So it contains of abstract of introduction, problem statement, objectives. So I'll be entering into my introduction. So it's basically a medium to high voltage system. Suspension and strain insulators are employed. Stay and Shackley insulators, on the other hand, are most employed in low voltage applications. So basically, that's what the theoretical part says. Pin insulators were the first overhead insulators to be created. So the first insulator which created was the pin insulator, and they are still widely employed in power network up to 33 kV. To ensure enough insulation, the insulator must be thicker as the voltage increases. So the more voltage increases, the thicker the insulator should be to get an efficient amount of insulating. So it is not feasible to create an extremely thick single piece porcelain insulator. In this scenario, we employ a multiple part pin insulator which consists of many appropriately constructed porcelain shells that are joined together by Portland cement to produce one complete insulator unit. So basically this is the explanation of how they come up with one complete insulator unit. So for 33 kV system, we typically utilize two parts pin insulator and three parts of pin of insulators. So we have two part pin insulator and also three part insulators. So basically I've merged a basic picture on our introduction part. So where it consists of shearing, line insulator, pod insulator, grading ring and post insulator, grading ring and line insulator, and also end of joint fitting. So basically that's what consists in our power in our this one. So objective of our project that we have carried out is actually to study the purpose of each insulating segment and the material that can be employed. So basically what are the materials that can be used to employ the project. So to create an insulator prototype model of the suspension type of overhead line insulator. So to create an insulator prototype, so we have created using utensils of kitchen, and also to design a suspension using cooking utensils like plates, cups and bowls. Okay, it's like people will be thinking it's weird to come up with kitchen utensils such as plates, cup and bowls. So we have come up with it and we have used a rod in middle, and we have different group has included different types of materials, insulating materials, to see their level of readings in different manner. So that were the actual objective of our group. And we also had problem statement. If one of the disc insulator in the suspension string becomes broken, it may be simply changed without having to replace the entire set. However, each disc of suspension type of insulator is more expensive than a pin and a post type insulator. So there is difference. So by replacing the entire set, it actually causes more compared to changing a pin or a post type of insulator. So that's the reason why that's one of the problem that we are facing. So to address this issue, this group, which is my group, has designed a high voltage suspension type overhead line insulator that is being made with cooking utensils. So we have chosen two types of insulator product, and we have come up with the project, and my teammate will be explaining more in detail on it. So yeah, that's all from myself. Thank you.
Hi, my name is Muhammad Izwan bin Usman. So next, I will explain about the drawing design for our prototype. The drawing is drawn using an AutoCAD 2021 software. As you can see from the picture, there are three main parts uh, of this prototype, which is the road, sheet, and the end fitting. Uh, in this prototype, the substance utilized is oil and cement combination. The overall length of the proto of this prototype is roughly around 50 centimeter, and the total creepage is 80 cm. Next, the other sheet. It is a combination of plates to become one insulator. The number of plate and bow you are used in this project is 3 pieces and 1 pieces of cup. The material used for cup, plates, and bowl is porcelain. Uh, this is because porcelain is more robust and simpler for us to punch the hole. The arrangement on this wood has also been determined so that the level of each component is not higher than the road. Finally, this prototype includes two hooks made from iron to link or hang it on the testing board. Uh, this is the comparison between ceramic and porcelain. As you can see from the table, the ceramic is thicker, opaquer, and heavier. See, look, the porcelain has a thinner, delicate, and translucent appearance. So when the surface of the material are thinner, it can be easily for us to make a hole in the plate. Next, ceramic is not as stronger or durable as than porcelain. This is important uh, because the stronger the insulator, it can hold the voltage higher than other materials. Lastly, even the porcelain has more advantage, but the costing for the porcelain is more expensive than the ceramic.
Hi, my name is Muhammad Nazmi bin Abdul Rahim, and I am from Group 7, and I'm going to present the methodology of the project flow. So this is our block diagram. So we starting as design planning. So we make a meeting to brainstorming to choose to come out the idea what design we gonna make for our insulator. So we and in the meeting we come out two proposal, two design idea, and we make and after that we proceed to making a proposal. So in the proposal, we have two design of the insulator, which is we use the plate of porcelain and plastic. And after we finish our proposal, we go to present our proposal to Dr. Sim, and then Dr. Sim approve one of our design, which is the porcelain. And in the porcelain, in the core root, we put substance half cement and half oil, and the plate is porcelain. And then after design have been approved, we go to buy the related item of the insulator, follow in the proposal design. So we buy the porcelain plate, porcelain mark, PVC rod, and glue, and also spray tin to spray our insulator. And then the substance was the cement and the oil. So we use corn oil to put in the our core road. So after we buy the item, the related item, we start to making the insulator. We do it together. So we drill the plate, and followed by the dimension of our proposal design, the length of the core root, the length of the insulator is plus minus followed by our in our proposal. And then after the insulator is finished, is done, so we go to the high voltage lab in UTHM Parit Raja, the main campus, to testing our insulator. And then we record the data and result. We also record the video. We snap the picture of the corona, and we test it in dry and wet condition. And we got in dry condition we got 90 kilovolt, and in wet condition we got around 30 kilovolt. And then after we finish the testing of the insulator, we complete the full report of our project to send it in author. So that's all from me. Thank you.
Okay. Assalamualaikum warahmatullahi wabarakatuh. And a very good morning to Dr. Sim and all my fellow team members. My name is Puan Azim bin Wa'aidah Fairuz. My matric number is AN190026. Okay, today I want to present about our group project for the subject transmission line. So firstly, for my part is to describe a little bit of knowledge about FMEA, which stands for Failure Modes and Effects Analysis of the Prototype Design and Application. We can see all the information is given in the table for further studies and references. So next slide is about our project cost. So I will present about our costing of material used in order to build up our prototype based on our 3D drawing sketch via AutoCAD. Part of the materials used, quantities and price is stated in the table. The material used is plate, bowl, cup, PVC pipe, cement, hook, oil, super glue, and PVC end cap. So while the cement and oil is used as the inner substances in the PVC pipe, all these material use is bought at the nearby store at Pekan Pago. So we can see that our budget is much more reasonable and affordable to invent this design chosen by our team members. So that's all from me. Thank you.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Amirul Afiq bin Muhammad Fauzi, matric number CN190130. So, I will present about safety risk assessment. The safety risk assessment is a form that students need to fill before run the insulator testing. So, the hazard that we found during the insulator testing is voltage shock from high voltage, which is 90 kilovolt. The person or equipment at risk is the person carry out the testing on the prototype and close to the equipment. Control measure applied to eliminate is safety case with an interlocking method. Second, the person applied PPE. The severity is 5, likelihood 4. So the risk rating is 20. Is the risk acceptable? Yes. So we said is yes. The second hazard is bent insulator. The person or equipment at risk is the insulator was used on the prototype. The control measure applied to eliminate is by using proper material. Severity is 4, likelihood also 4. So the risk rating is 16. The risk is acceptable, yes. The third hazard is fire. The person or equipment at risk is the insulator that was exposed to the fire. So the control measure applied to eliminate is use anti-fire material. The severity is 3, likelihood is 4. So the risk rating is 12. So we answer the risk acceptable is yes. And then the fourth hazard is spark. Person or equipment at risk is the insulator that exposed to the spark. The control measure applied to eliminate is use anti-conductor material. The severity is 4, likelihood 4, and the risk rating is 16. And then the last hazard is ice exposed to the saltwater. Person or equipment at risk is the person that sprayed the saltwater to the prototype. The control measure applied to eliminate is using or wearing safety goggle. So the severity is 2, likelihood is 3, risk rating is 6. Next, we move to the laboratory high voltage testing. So during the testing, the student have to run two conditions. So the first one is dry condition and the second is wet condition. So in the dry test condition, they also have a few procedure that we have to follow. So the first step is in dry test, before entering the cage, the power supply must be turned off. Second, after entering the cage, connect the insulator to the supply and ground. Third, permission will be given by the laboratory assistant to close the cage and make sure the light is turned off. So we can see the corona clearly when it's happened. Fourth, the lab assistant give instruction to turn on the supply. 5. Student will adjust the voltage control panel to increase the supply voltage until the spark is shown. 6. During the test, students should be careful not to expose themselves to risk. 7. Record the maximum voltage that the insulator can support. 8. Student power off the power supply. 9. Which is the last step is take off the insulator. So after we finish the dry test on the insulator, we move to the wet test. So the first step is representative of the group will spray the prototype with salt water after entering the cage. Second, the insulator connect the supply and ground. Third, permission will be given by the laboratory assistant to close the cage and make sure the light is turned off. Student will adjust the selector knob. to increase the supply voltage until the spot is shown. 5. The maximum voltage for the insulator will be recorded by the student. 6. The power supply needed to be turned off as the insulator finish. The last step is remove the insulator.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zulkarnain bin Murtaza. I will share about high voltage testing result based on our team prototype insulator. So for our prototype insulator is made from porcelain and the rod is PCV. Inside the rod, we insert half cement and half oil. Okay, for on that going to running this test, we put two cable, which is upper and the middle of the rod to test only one set of the insulator. We spray our prototype with silver gray to make sure the prototype is more proper, and we use metal hook up and down. So so for this test, we only test for dry test and wet test, which is for dry test, as you want to see, the spark is showing at the moment as 90 kilowatt. To see you can see this, the picture for the middle picture, this the dry test for the maximum 90 kilowatt. The spark is beginning from the upper, from the hook, and going down to the middle at the middle that the cable insert. So the next we going to run the wet test, which is we spray the insulator with the salt water for as assume this prototype are going on the rain weather. Okay, as you want to see, the maximum that for our prototype test is 30 kilowatt only, and we're not going to maximum above the 30 kilowatt because the spark, as you can see, the spark is very wide better get greater than the dry test. So for this conclusion for this testing, as I said, the prototype on our prototype is suitable for dry test only, but for the wet test is not suitable purpose. That's all for me. Thank you.
All right, right now I will present about the recommendation of design improvement. So the first one is by adjusting the length of the rod. So during the insulator testing, the length of the rod is 44 centimeter. By lightening the core rod, the gap between the discs can be lightening. This is because the gap between the discs will affect the result. The second recommendation is by grading the insulator. One way to obtain varied capacitance is to grade with different insulator dimension. The top unit has the smallest capacitance, and as they move down the stack, the capacitance steadily increases. The closest insulator is the bottom unit. This approach tends to equalize the potential distribution across the unit since voltage is inversely related to the capacitance. The last recommendation for design improvement is by using a guard ring. Guard ring is essentially a metal ring that is electrically attached to the wire around the string insulator's bottom unit. Shunt capacitance are generally cancelled out by the guard ring introduction of capacitance between metal link and the link conductor. As a result, each disc receives approximately the same amount of charging current, increased string efficiency. So at the end of the presentation, which is conclusion part, in the nutshell, the student have studied the purpose of each insulating segment and the material that can be employed. An insulator is to prevent current flow toward the earth and can support the overhead line conductor on the poles. It is critical to the operation of transmission line. An insulator may be designed utilizing a variety of materials such as rubber, wood, plastic, mica, and so on. Besides that, the student successfully created the design of insulator prototype, model of a suspension type overhead insulator. The design were created by using the AutoCAD software. Before creating the design, all the team's members will cooperate with each other and share their ideas during the meeting. In the design, it consists of a hook, bolt, cup, plate, and a rod. The rod that students use will be PVC and wood. So the design was stated on this proposal. Moreover, the student able to design the suspension using cooking utensils like plates, cup, and bowl. This is because cooking utensils such as plate, cup, and bowls are made of porcelain. After the insulator testing, a project achieved to get maximum voltage which is 90 kV in dry test, while in wet condition, the insulator managed to hold until 30 kV. Some improvement need to be made by us. The improvement carried out are intended to ensure that our prototype can withstand high voltage in wet condition. Okay, I think that's all from us. Thank you.